All right, today we're going to do section 1.1 in the book. It talks about, it's all review, and we're dealing with numbers. Why? The classifications of numbers. Math is a language. If you were to take a Spanish or a French class, any language, you start off with knowing the terms, the words. You have to know the translations. Well, math is a language. You have to know what these words are, because when I ask you to solve an equation and they say use the set of real numbers or integers, you got to know what words, what numbers they're talking about, what numbers do we get to pick from, okay? So let's start off. All numbers are real numbers. But let's start at the very basics. Let's go back in time, everybody. When you were a baby,
natural.
what is the name? What are the first, when your parents teach you how to count? What's the first number they start with?
One.
Then what?
Two.
Then three.
Then four.
Do you guys know what those numbers are called?
Natural.
Those are natural, or they call them counting.
That's just a number they used to get.
So examples of natural counting numbers are 1, 2, 3, 4, 5, and so forth. When you learned how to count, did they say 1.5? Or 1, 1.5, 2? Did they say 0? No. What's the next number that is introduced to you as you get older?
Whole numbers.
Whole numbers. What is different about natural?
You're zero now.
They added the 0. So we have to compare, like if you have nothing. 0, 1, 2, 3. So the set of natural and counting numbers with an addition of 0 makes the set of whole.
Oh, I wish we could spell.
I wish we could spell. I wish this was English class.
You'd lose a degree, I think.
Whole. Now, why did I write that?
So
You know
that
why?
you make the emphasis on the zero.
So you can see that 0 here in whole has it has a 0. So some people get confused on that. Okay. So now you get a little older
Integer.
and you get to elementary school, 3rd, 4th grade, and what do? They draw this number line.
You're like,
And they do 0, 1, 2. What other numbers do they put on here?
negatives.
And so
My
forth.
life.
Do you know what whole numbers and their opposites are?
Integer.
Those are called the integers. The set of integers are whole numbers and their opposites. So negative, you could do dot, 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 -2, -1, 0, 1, 2, dot, dot, dot. So that pattern continues. Now, is 1.5 an integer? No, it's strictly these numbers here. This number's an integer, this number's an integer, this number's an integer, integer, integer. And the pattern continues. So, are these the only numbers in the world? Are there any numbers that are in between here? Here? What kind of numbers fall between 0 and 1?
Rational numbers.
We have rational numbers. Can you be more specific? What does a rational number look like?
It's a fraction.
It's a fraction.
It's not a whole number.
It's not a whole number? Why not? Why can't I turn the number 4 into 4 over 1? That's a fraction.
No, I mean like in comparison, it's like 1 point something. You know what I mean? Like it's not just like.
But they are also integers, whole numbers, and
Yeah.
counting numbers. So a rational number is the set of numbers that can be written as a ratio. Ratio is a fraction of 2 integers. Examples include all integers, all whole numbers, all natural numbers, all fractions, and all repeating and terminating decimals. So it's repeating or terminating. What does terminate mean? I'm gonna write ing. What does terminating mean? It ends. It ends. So repeating and terminating decimals. Can you give me some examples of a rational number?
1/3,
1/3,
2/3.
0.3, repeating, 2/3, 0.786941, it ended. The square root of 9. Why is the square root of 9 a rational number?
Because it's expressed as a ratio.
Because it's 3, this is equal to 3, and 3 can be written as a ratio, 3/1. Now, if something is not rational, what is it going to be?
Irrational.
Irrational. I think of irrational as crazy. A crazy number. What does that mean? When your mom's irrational, when you came home from your friend's house 5 minutes late and she grounds you for the whole year and takes away your car and your phone and starts acting like Mom, I was only 5 minutes late. She's acting, you say, Mom, you're being irrational. Okay, think of irrational is a non-repeating. It does not repeat. It does not terminate. It's crazy. It goes on and on and on. It does not repeat and does not end. Give me some examples of numbers that do not repeat and do not end. Pi. E. Square root of what?
-1. Or is it
No,
2?
that's going to be an imaginary number.
Okay.
Square root of 2, square root of 3, square root of 5, some of the square roots. Now, not the square root of 9, the square root of 9 is rational.
That's the first 4 prime.
Any of these are examples. These are numbers that don't repeat and do not end. Now, what are all of these numbers? These are all real. All numbers are real. They're all of these. It's a combination of all of these. So let's do some examples. Can you list all of the whole numbers that are greater than 2?
Yeah.
What are they?
Huh?
Give me all the numbers that are greater than -2. So here's -2.
Greater than everything greater than or equal to
Give me all of start giving me the list of all numbers that are greater than -2. Is -1 a whole number?
0, 1, 2, 3, 4, 5, etc.
Do dot, 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 just like that. What if I asked you to classify the number -7? Is -7, start with here, is it a natural number?
No.
Is it a whole number?
Nope.
Is it an integer?
No.
If it's an integer, it's also a rational and a real. So we're going to say the number -7 is a integer. It's a rational and it's a real. These are all the classifications. If I said classify pi, pi is a irrational and a real. They're all real, so you need to include that in every category. Okay? Next. When we were in elementary school, when we compared things on a number line or graphed them, we did a straight horizontal number line. So if I said 2x equals 8, x equals what? 4. How would you graph that? And x could be apples, oranges, whatever. How would you graph the solution?
It's not in the color, so
What would
just
you
put a
do?
dot at 4.
So we did this, and we put a dot here at 4, right?
Yeah.
Now, what if we have two quantities? We have 2x equals 8, x is 4, and then I said 2y equals 12, y equals 6. Well, this number line represents the x values. We have to do another number line. We're going to make it vertical, up and down. So we're going to go here 0. How do we count if it's vertical? Is up positive or negative? Should I put negative numbers here? So this is going to be 1, 2, 3, and then. So when we start comparing two different quantities, x and y, we take this vertical number line and you're going to put it right on here, and guess what we've created?
Graph.
A graph. This is the rectangular. Why is it rectangular? Does it look rectangular?
No.
The rectangular coordinate system, where we create 4 quadrants. We start in this quadrant. In this quadrant, and by the way, you guys know ordered pairs go x comma y. Do you remember what this point is called?
Origin.
That's the start place. So I want you on your graph here, right here, that point is called the origin. And what's the name of the origin? 0, 0. Now, in this corner, upper right-hand corner, these are all points in quadrant 1. And we go counterclockwise. We have quadrant 2, and you know this deal very well by now, in quadrant 4. Now, when you plot a point, what does that mean? What does it mean to plot a point?
Put it in x.
You're going to graph it. You're going to place this point, find its location. How do you get to -2, 4? You start at the origin, and you're going to count, the first number is your x-axis. You're going to count 2 units left, because it's -2, and the second number is your y value. You're going to go 4 units up. That is the first point. We'll call this point A. In what quadrant is point A in? It's in quadrant 2. How about the next one? How do you plot -3, -5? You start at the origin. You're going to count 3 to the left and 5 down. 1, 2, 3, 4, 5. We'll call this point B. And point B is located in what quadrant? 3. And where is point C? 0, -3. Is it here? Yeah? Is it here or is it here? It's here. 0, -3 is here. You're going to go move left or right first. So if you're starting at the origin, you're not moving left or right, and then you're just going to go down 3 points. So that's C. Question for you. What quadrant are you in? You're on the y-axis. You are not in a quadrant if you're on an axis. You're not in 3 and 4. You're on an axis. So what quadrant? That's a trick question. You're on the y-axis.
May I steal you for a moment?
I'm videoing
Tell me a good time to come back and that's what I'll do.
at the end of this hour.
Will do.
Okay. In what quadrant or S, plural, do you know what this means, X, Y? What does that mean, X,
With
Y?
both x and y are greater than 0.
What does it mean when you put 2 letters together, like that? What are they asking you to do? Multiply. How do you multiply? What does greater than 0 mean? Here's 0. If it's bigger than 0, what kind of numbers are these? They're positive. Positive numbers are greater than 0. Less than 0 are negative numbers. So in quadrant, let's go through. In quadrant 1, can you tell me all of the x and y values? Are they positive or negative?
All positive.
They're both positive. In quadrant 2, is x positive or negative?
Negative positive.
Negative positive. In quadrant 3,
Negative.
negative, negative. And in quadrant 4,
Positive.
positive, negative. So, whoops, I wrote -1. positive, negative. Can you tell me, if you were to multiply the x and the y value, which one would give you a positive number? What quadrants? 1 and 3. Why 3? Isn't a negative and a negative, when you add it up, don't you get a bigger negative? You're not adding, you're multiplying. Good job. So in what quadrant is the product of the x and the y values greater than 0? That would be 1 and 3. How about the next one? In what quadrant or quadrants is the product going to be negative? Less than 0 means negative, and that would be 2 and 4. Good job. Questions? Okay, next page. This is all review, guys. Domain and range. Do you guys remember what domain and range are?
Domain is your x
Okay. An ordered pair is a relation. When you group a bunch of ordered pairs, it could be a T-chart, it could be a set of points, we have a relation. These are all relations. So if I give you this relation, this is a relation, and I asked you to name the domain of this relation, can you tell me correctly how to do it? This is all review. How do you do it? I'm going to give you a hint. Set. How do you list the domain? And the domain is the x values or inputs. -3, -2, -1, and 3. And how do you do the y values, which is called the range? Now, can anyone tell me what I just did? I put them in order. You're going to organize your domain and range. You're going to organize it from least, smallest to greatest. And do not repeat. Do not repeat. Do not repeat. Okay? So let's go through these ones. Can you state the domain and the range? This, see this bracket here? This is a relation, because I grouped them together. What is the domain of this relation?
0, -2, or never mind, it's backwards. -4, yeah.
Take your time. -4. Did I do it right? How about the range? -2 looks like it's the smallest. Then what? 1. Then 1. Then what?
3, 6.
Set.
Okay? Next one. Here's a relation. Can you tell me the domain? I like to do this as simple as that is. Why do I do that? So you don't mix them up. I'm going to say -3, -2, 2, and 3. And the range would be and the last one. This is more of a pre-calc problem. What do you see in this T-chart? X and Y. This is your domain, and this is your range. Remember, domain is your X values, range is your Y value. This is your domain. Can you list these numbers? -2. What's this? What does this plus minus mean?
Positive
We have
and
3 and -3.
So shouldn't you have put?
You're going to separate them.
Yeah.
So you're going to write for your domain, what's the smallest number so far?
-3.
-3, then -2, then 3, 4, and 9. And how about the range? That's easy. -3, 0, 3, and 4. Okay, now what did I call all of these sets of numbers? They are relations. We have a special kind of a relation, and that's called a function. A function exists is when for every x, There's only one y value assigned to it. So in other words, you guys remember it like this. If you see any x value repeating, it's not a function. It's not special. It's just a relation. So let's go through these 4 examples. Is this one a function, yes or no?
Yes.
Yes? It's good. How about this one?
No.
No. Is it these 2? Not a function. Because the x value repeated here. How about this next one? Those are all unique. This is yes. And
Yes.
right off the bat, is this yes or no? I'm going
Yes.
to point to that and trick you. Is that a function, yes or no?
Yes.
Yes.
Why?
Because it's a 3 and there's some negative or positive. So
No number repeated. Now, what if I would have had a plus or a minus on this side? Then yes. Because you would be saying, let's say if I put a plus or minus here, you would say 9 goes to 3 and a negative 3. So 9 would actually be repeating if you have 2 plus or minuses on this one. So this is a pre-calc question that will be on your test. You gotta know that really, so in other words, what are we doing in this class? We're learning what you learned last year, but we're going deeper. We're taking the material and making it a little bit more rigorous. Right now, it's just review with a sprinkle of new stuff, okay? All right, function notation. You guys are really good with this function notation. So in 9th grade, and actually even in 9th grade now, they're doing function notation. This is a relation. This is a relation. We're comparing 2 quantities, x and y. Now, if it's a function, we use this fancy schmancy notation, the fancy f with an x. What does all this stuff mean? This f is the name of the function, and they'll use f, g, h a lot, more frequently than anything. This little piece right here, that's your x value, your input. That's your domain. F of x, this whole thing and this whole thing are the same. Both of these together give you the output or the range. Okay? So for example, now I know because they use this fancy notation that this, for every x, there's only going to be one y value. So if you saw something like this, evaluate f of 3, what do they want you to do?
Plug in 3 factors.
Plug 3 in here. So what is 2 times 3? 6 plus 3 is 9. So when x is 3, what's the output? 9. Okay, now, the last thing I want to do with you guys, I am going to have you take this graph, I want you to doctor it up for me. I want you to put a closed circle here, and I want you to put an open circle there. We're going to ignore that little tail. So this is -5, -1. This ordered pair is -5, -1, and this ordered pair is 4, -2. You have an open circle right there, okay? Now, do you guys remember interval notation with the brackets and the parentheses?
Oh.
What's the difference when I ask you to graph x is greater than 3?
Remember.
You guys remember this? Do you remember the new way to do it? Instead of an open circle, what do we use? A parenthesis. So open circle, you're going to use parenthesis.
Circles and bar.
Closed circle, which is with the bar, is a bracket. You remember this? Okay. So now let's talk about what the domain, we're going to state the domain of this. This is a function. How do I know it's a function? Remember it passes the vertical line test? Okay, it's a function. How do you state the domain? Well, what is the domain? The domain is the x values. X goes left and right, it's this axis. So we always read, if I opened up a book, we read left to right, right?
Yeah.
We start with the smallest number. What is the smallest x value? What ordered pair is this? This is -5, -1. So what's the x value? The domain is the x's. So we're gonna say -5, comma, and it goes to 4. Now, at these are critical values. I need to place a bracket or a parenthesis at each of those numbers. Bracket includes the number, a parenthesis goes right up to it. So what would you do? You're gonna put a bracket here